Ever pondered upon the birth and death of the stars that twinkle in the night sky? Well, today we're setting off on a cosmic journey to explore the life cycle of these celestial bodies. Stars, as we know them, are formed within vast molecular clouds in space, often referred to as stellar nurseries. These nurseries are the cradles of star formation, where conditions are just right for the birth of a new star. But the life of a star isn't all that tranquil. It's an ongoing struggle, a tug-of-war between two powerful forces. On one side, we have the relentless force of gravity, attempting to collapse the star. On the other side, we have the light pressure from nuclear fusion, pushing to expand the star. This constant battle shapes the life of a star, leading to various stages and ultimately, to its dramatic end. Now let's dig deeper into the life cycle of stars and unravel the mysteries of the cosmos. The birth of a star is a spectacular cosmic event. It all begins in the heart of a cold, dense molecular cloud where the magic of star formation takes place. This cloud, filled with gas and dust, starts to collapse under its own immense gravitational pull. As the collapse continues, a core begins to form, and we call this a protostar. This protostar isn't just a stationary object. Oh no, it's an active, growing entity, steadily accumulating mass from the surrounding cloud. It's like a cosmic baby, feeding and growing, preparing for its grand debut. The moment of truth arrives when the protostar reaches a high enough pressure and temperature, triggering the process of nuclear fusion. This is the heart of a star beating for the first time, converting hydrogen into helium, releasing energy, and lighting up the universe. The star now begins its long journey on the main sequence, where it will spend most of its life. A star spends the majority of its life in a stage known as the main sequence. This is the period of stability, where stars like our very own sun burn bright, converting hydrogen into helium in their cores. This nuclear fusion releases enormous amounts of energy, which is what makes stars shine so brightly in the night sky. The main sequence isn't the same for every star though. It's a bit like a cosmic dance where the steps you take depend on your initial mass. The bigger the star, the hotter and bluer it burns. Smaller stars, on the other hand, burn at a cooler temperature, appearing red. Our sun, a medium-sized star, is currently in its main sequence stage, steadily burning its hydrogen fuel for about 5 billion years now. It's estimated to continue this for another 5 billion years. So, don't worry, we've got plenty of sunlight left. But what happens when a star exhausts its nuclear fuel? The death of a star is as spectacular as its birth. This celestial event is as grand and awe-inspiring as it sounds. The final stages of a star's life are dictated by its mass, with different outcomes for low-mass and high-mass stars. Let's start with low-mass stars, like our sun. As their fuel runs low, they expand into red giants. This phase is marked by the star swelling up to 100 times its original size, its outer layers cooling and reddening in the process. The star's core, however, becomes increasingly hot, triggering the fusion of helium into heavier elements. Then comes the planetary nebula phase. The star, now a red giant, puffs off its outer layers, creating a beautiful glowing shell of gas. This shell, the planetary nebula, expands outward, leaving behind the hot, dense core. Finally, the core, now devoid of its outer layers, cools and contracts into a white dwarf. This is the star's final resting state, a dense, dimly glowing ember the size of Earth, yet with the mass of the sun. It will spend the rest of its cosmic days slowly cooling and fading away. Now let's turn our attention to high-mass stars. These behemoths, with masses more than 8 times that of our sun, have a more dramatic end. They too expand into red supergiants, but their cores reach such high temperatures that they can fuse elements all the way up to iron. The fusion of iron, however, doesn't release energy. Instead, it consumes it, leading to a catastrophic collapse of the core, followed by a spectacular explosion, a supernova. This cosmic blast can momentarily outshine an entire galaxy. The aftermath of this cosmic spectacle can result in either a neutron star or a black hole, depending on the star's mass. Neutron stars are incredibly dense. A teaspoonful of its matter would weigh about 1 billion tons. Black holes, on the other hand, are regions of space where gravity is so strong that nothing, not even light, can escape. Thus, every star, whether it ends as a white dwarf, neutron star, or black hole, has traced a fascinating journey from a simple cloud of gas to a cosmic spectacle.